Hi guys, I wanted to talk a little bit about the phase change PowerPoint that I gave you yesterday and expand upon it a little bit today. So I'll quickly just review this first slide that was sort of self-explanatory, but at the same point, I want to make sure that I go over it with you so that you understand it. So when we talk about a phase change, we're talking about a substance that is just going from a solid to a liquid or a liquid to a gas or any different combination, and nothing's happening to the actual molecule when it undergoes a phase change. If you have two H2O molecules as a solid, when they melt, they're still H2O molecules. They're just moving next to each other. So you put in some heat, and heat causes them to speed up, and they separate, and they become a liquid. This is still H2O, this is still H2O. As you continue to add heat, and they go faster and faster, they separate and they become a gas. And as they become a gas, again, you still have H2O molecule and H2O molecule. You've not done anything to those H2O molecules. All you've done is cause them to go further apart from one another and move a little bit faster. And so when we write a chemical reaction showing a phase change, it shows a physical change. If you look down here at the bottom, CO2 solid going to CO2 gas, they're both still carbon dioxide. All that changed was the phase. And so all that happened as you went from a solid to a gas was the particles sped up and went from being tight together as a solid to being further apart as a gas, okay? And so we have names for each of these different phase changes, and I'll go over them real quick. So starting with the most simple one that you probably already know, when you go from a solid to a liquid, that's called melting. Think about a solid piece of ice, and you leave it on your counter, and you come back, and now it's liquid. We say it is melted. The reverse of that, if you put water into your freezer, you come back, it's made ice cubes. It's gone from a liquid to a solid, and we call that freezing. You've all boiled water before, and you see that it's a liquid that starts steaming and becomes a gas. As a liquid goes to a gas, we call that process evaporation, and it boils in that process. And boiling is the process, and the name for the change is evaporation, when liquid goes to a gas. Keep in mind, this isn't just water. This can be any substance on Earth that can go through any of these different changes. You've all gotten out of the shower before, and your mirror was fogged up. And what happened there was condensation. The water vapor from your shower, when water gets hot, it turns to a gas and it fogs up, or it's filling your bathroom. And when it hits the mirror, glass stays cold, and it causes that water vapor in the air to hit the cold mirror, and it turns it back into a liquid, and that fogs up your mirror. And it'll start forming drops and running down the mirror eventually until your mirror's clogged, unfogged. And so that's condensation, when a gas becomes a liquid again. And that happens when it cools down. So all these left arrows going to the left involves cooling down. And all these right arrows involve heating up. There's two that you probably aren't familiar with: sublimation and deposition. And deposition is also called solidification. I actually use solidification a little bit more than deposition. Sublimation is when a solid goes directly to a gas. It doesn't first melt to a liquid and then the liquid evaporate to a gas. That would be melting and then evaporation. Sublimation is you have a solid and you see it smoking, and it's literally turning into a gas before your eyes, and the solid will disappear entirely, and all you'll be left with is a gas. And an example of that is going to be dry ice. Dry ice, you might have worked with before. It's solid carbon dioxide, which is interesting. We breathe out carbon dioxide gas. So every time you breathe out, you're breathing out CO2. If you freeze or you cool down your breath, it turns into a solid called dry ice. And it would take a very cold temperature to do that. And dry ice then, when you put it out at room temperature, starts to sublimate. It goes directly to a gas. It doesn't melt. It doesn't form liquid CO2. You can have liquid CO2, but that's a different set of circumstances that involves pressure and some other stuff. The last one that you probably don't know about is when you cool a gas and a gas goes directly into a solid. It doesn't first condense into a liquid and then the liquid freeze. It goes from a gas directly to a solid, skipping the liquid phase. That's called deposition or solidification. There's not a lot of examples of this that occur in nature, but the most common one we've all seen is a frosted windshield. It's humid outside, and it's cold, and as it gets cold during the night, the humidity, which is water vapor, just water in the air, the water vapor in the air it hits the windshield, which is very cold, and causes it to go directly from a gas directly to a solid, which is frost. This is different from having ice on your windshield. If you had ice on your windshield, that would be a liquid, and then the liquid would have become a solid. So ice is different than frost. This was a gas that went directly to a solid. Okay. So what's happening in these phase changes? It's really important to be able to visualize the particles. In a solid, all the particles are really tight together. As a solid gains heat, heat is the only thing that can take a solid and make it go into a liquid. I shouldn't say the only thing. Pressure could be involved too, but all you need to know is that heat's involved. And so as you heat up a solid, the particles start to move faster, and then they start to separate, and they become a liquid. As you continue to heat them up, they move faster and faster and faster, and they fully separate and become a gas. So again, here you can see 15 atoms making up a solid, obviously a very small piece of solid. And if that solid melts, this is what it looks like. They're a little bit further apart from each other. We call that a liquid. They're all still close to touching one another though. Then when these spread out even further, it's called a gas. Okay. And so the thing that's involved with that is heat energy. And we'll talk about heat later in the week, but heat is a form of energy. And we measure heat using a thermometer. And heat energy, when it's put into a solid, it causes it to start increasing its speed. That energy is going into it and it's increasing the motion of the particles. Think about when you gain energy and you get really, really hyper and you start moving around fast and everything. And when you lose energy, you feel really slow and you're just laying on your couch or laying in your bed, right? And so when you gain energy, it just makes you move faster and more excited. And so the particles get more excited as well, and they move faster. And so the energy that's associated with motion or movement, it's called kinetic energy. You can look at the speed of something and determine how much energy it has. If it's moving really fast, we say it has a lot of kinetic energy. If it's moving slow, it has less kinetic energy. And we can measure that energy by taking the temperature of a substance. If it's at a very high temperature, we know it has a lot of kinetic energy. The molecules are moving really fast. If it's at a low temperature, we know that it has less kinetic energy. The molecules are moving slower. If you take a liquid that's going like this, and you put it in the freezer, it starts to lose its energy. It's losing its heat to the freezer. And it starts to slow down and become a solid again. And that's why it turns to ice. It's losing its energy. When it loses its energy, it slows down. And it loses its energy, heat actually leaves the water and goes out into the freezer, because heat always moves from area of more heat to area of less heat. We can predict the kinetic energy by looking at the temperature exactly. For example, when something boils, we know that it's at 212 degrees Fahrenheit. So I hope this helped you a little bit, and I will talk to you guys during your meeting on Wednesday.